Okay, good afternoon to one and all present here. I am Rashmita Kumari Mahapatra, Assistant Professor of UNTC Department, TCT Mumbai. Welcomes you all to the first session of IEEE sponsored 1 week faculty development program on recent tools for integration of smart systems. Today's keynote speaker is Mr. Abhimanyu Chauhan, Senior Research Manager, Geospatial World, Noida, and the topic is Introduction to Remote Sensing and its Applications. I welcome you, sir, to the FDP.
Thank you so much.
Before starting our keynote, I want to introduce sir. Mr. Abhimanyu Chauhan is a remote sensing and GIS professional with around 8 years of experience in generation and interpretation of geospatial data for various applications in the field of weather and climate, geoscience, agriculture, hydrology, soil, etc. His key roles are image processing techniques for multispectral and hyperspectral data, GIS tools, mapping, and GPS. He is well updated with the advancement in the technology and scientific tools in the industry. He is currently working as Senior Research Manager, Geospatial World, Noida, India, handling the Department of National Geospatial Agencies, which looks into the Earth observation activities of national agencies throughout the globe. So before that, he worked as project scientist, India Meteorological Department, Satellite Meteorological Division, New Delhi, and ISRO, and other reputed institutes. So without any further delay, I will hand over the session to Mr. Abhimanyu Chauhan to start the session.
Thank you so much for my introduction. And first of all, I would like to thank the committee members for inviting me on this platform for keynote lecture. So it's like a great platform, and I would like to thank the participants also, those who are uh, interested into that. So without delay, I think let's go directly to the presentation there. And one more thing, before starting presentation, actually, I would like to convey a message, as most of the participants, they all are from different industry background. Like, I mean to say, like, they are having different domains. So my core focus of giving this presentation will be like how we can integrate this geospatial technology, basically the remote sensing and GIS we talk about. So how we can integrate in different domains, basically. Okay, so I request you people, like, must have some, like, if it will be very good if you have some questions like how we can integrate in your domain. Okay, like whether it is electronic, whether it is civil engineering, whether it is computer sciences or environmental, whatever it is. So everywhere we are able to integrate this technology. So that is my main area of focus. And second is like for upcoming, like, students or like existing students, how they can be benefited with this technology for their projects or developing applications. So I hope that's enough for the introductions, and let's just start. I, Abhimanyu Chauhan, as a Senior Research Manager, National Geospatial Agency, Geospatial World, going to give a keynote lecture on Introduction to Remote Sensing and GIS Applications. So, first question is, what is why remote sensing and GIS? Like, so this is kind of, we can say, this technology has the driving force for the future globe. And this technology somewhere has changed the whole perspective of uh, data or getting informations or sustainable development. This is actually in this slide, actually I have shown a kind of whole environment where, like, how we define remote sensing when it comes to uh, an in action. So like this is kind of environmental mapping scenario where, like, you can see currently we have 4 platform it is ground based when we are doing sensing from the ground instruments. Second is the aerial low altitude, then aerial high altitude and airborne, and fourth one is the satellite based where we our main focus will be. And this, the left side of the satellite data you are seeing is all the data sets, the different products which we are getting from the satellites scanning, like, and how they are can be, they can be used in different um, you can say domains, environment, like it's related to ecosystem and environment, so it's environment composition functions. And one more thing, the upgradation we will talk about, the science where we were failing earlier was the gathering the information in the dark side of the earth, where we could not able to get in the visible spectrum. So that also we will talk about, like how, where we got the advancements in scanning the earth in dark portions when it is night, when there is no sun. So this is kind of one whole picture. So yeah, so what is remote sensing basically? So remote sensing is a technology, uh, and if in a normal language, like in a layman language, if I explain it, so it's like anything which can be sensed without going into the factual contact from a distance is remote sensing. So in our daily life also, for example, if we are taking a photograph, it's like ideal example of remote sensing, where we are not going to the object, but from the distance we are getting the information from the object in the form of picture. So this is not a picture, but this is only image, because it has more information than a picture. So I'll explain how it is different from that one. So basically, remote sensing whole mechanism have some steps which are standards, which like every satellite or any data procedures have to go through. So first is the energy source. For remote sensing activity, any kind of data capturing, we need a energy source. So currently, for our earth, our the sun is acting as a natural light source, where we are, our most of the satellites are operating in daytime, and for night time we have our microwave data sets, where we have SAR systems which are scanning in the night time, so we are getting both the times. So in night time we are having our own energy source which is getting bombard on the this earth surface and getting reflected back to the sensor, and that information getting converted into pixel format. So second is the radiation and atmosphere. So when the light is traveling from the sun, it has to go through the atmosphere, and it has to interact with different gaseous particles, different molecules, water molecules, and other uh, cloud and other things. So it creates a lot of noise, and a lot of light get distorted, reflected, refracted, and after coming back, and it has to go back again to the satellite. So like that, a lot of information getting lost while into that. So it's like it's a natural phenomena. So we process that thing separately. We will cover that also, like how we are dealing with the radiation and the atmospheric noise. Third is the interaction with the object. So when the light is falling on the object, so it interacts differently, because light has, every object has different character to absorb wavelength. So depending on the object, how much light it is reflecting, how much light it is getting absorbed, so the amount of light reaching to the sensor is defined, basically defining the object and the color. So fourth one is the recording of the energy by the sensor. So sensor is designed in such a way that it can detect light, and it can record that light into the format of digital numbers. Basically, it doesn't record direct geophysical information from the surface. So basically, it records only the digital values which is coming on different frequencies. So once the sensor is recorded that all the frequencies into the digital numbers, so those digital numbers transmitted again back to the uh, ground stations, and where this processing starts basically. So while when these digital numbers are reached to the ground stations, there we have different scientific algorithms which can convert those digital numbers into pixel, and the pixels group together and form a image. Basically, we call it satellite image, and then we do a lot of analysis, getting information out of them, and developing applications. So this is one system, how it works from starting to end. So actually, this remote sensing electromagnetic spectrum, basically this technology rotates around this 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 small part, actually electromagnetic spectrum. So light is everything to this technology. Without this electromagnetic spectrum, this is nothing. So this is kind of a generator to this uh, science, basically. So what happens is when we talk about satellite data, so it has all the as I told, it records light which is coming from the surface and then convert into pixels. So those lights are having different frequencies. So as you see the below image, which is in color, so we basically, our eye can see only the visible part of the spectrum, where it is 0.4 to 0.7 micrometer. So this much only we can see. So basically in a photograph, we just we see the colors in different combinations and all. But we can't see beyond that, like infrared, microwave, so these, or ultraviolet. So for these we have these specialized sensors. So these sensors have the capability to store informations of different wavelength also, and that information we transform into satellite images, and can have the more versatile, actually, you can say the more dynamic informations of any object we can have. So when like, as you see, this is like, I some of the features we have shown is water, earth, vegetation, ground, surface. So they all are having, showing some of the peaks. Actually the peaks are depicting like how these features are reacting to light at what wavelength. So basically if we take the vegetation, it is showing like very high peak at around near infrared band. So so this vegetation specifically have the character to reflect more into the near infrared zone. So if we record this information, so we can have the maximum information of agricultural part or vegetative area on the surface very easily. So that's why we have developed our sensor in such a way that it can record visible, ultraviolet, some of the like part of ultraviolet, near infrared, and thermal infrared, microwave. So maximum we our sensors are uh, delivering data in visible, near infrared, far infrared, and thermal infrared. And some of the specialized sensor for night scanning, nighttime scanning, or you can say meteorological aspect, we are using this microwave band, because it is independent of time and the weather conditions or atmosphere also. So these are the actually scenarios. And if you see this above also, same actually, this electromagnetic spectrum have kept here one more with you can see some peaks are there. So these peaks are not reflectance, actually these peaks we call it atmospheric window. So what happens is, what it is showing, the peaks, actually these peaks are the areas where we can get the information recorded on the satellite data. And wherever these white blanks are showing the depressions, basically these are the areas, dark spots, where we cannot get the information uh, at our sensors, because these are the frequencies which cannot reach to the earth, because these are frequencies get absorbed by the you can say the compound or elements in the atmosphere. Some are gaseous compounds which are very reactive to these frequencies, and they absorb those energies in the atmosphere itself, and it doesn't reach to the surface, basically those particular frequencies. So we cannot record that data. So um, so that's why we does not go into that. So if you see after thermal infrared, there is more whiter part, means like more depression is there. So we are not recording into that area. And after that we are having the radar systems, so passive microwave, so it is having the highest window with us, continuous window. So we are using this also very frequently in agricultural studies, and others are using, getting used for other like land use, land cover, vegetation, and other aspects. Though this is the uh, course, you can say this is the everything of remote sensing. So when we talk about anything, it will run behind this, like all the concepts, any information coming on the satellite image, all is related to this spectrum only. So we every time we will correlate this spectrum with all the informations. Later on we will see how these spectrums are like getting defined. So next is the type of satellites. Basically, when we talk about the satellite data, so it must be uh, uh, like we have the questions like how it scans the Earth surface, and how we collect the data, how what is the frequency. So all this information we need to know about. So the first thing is, we actually currently we have two kind of satellites uh, majorly. One is the polar orbiting satellites, and other one is the geostationary satellites. So these are the classes of two satellites basically. So most of the countries, those who are having their own space agency, so they have both kind of satellites, because every country wants to cover their meteorological or climatic changes aspect, and the regular changes or other high resolution data also they required. So for high resolution data, we need a low orbit satellites, and it should be continuously moving, changing the path, so that it could cover whole of the area. So what happens is, like when we talk about the polar orbiting satellites, so generally these satellites are revolve around north south poles of the earth, and it is they are revolving around in such a way like uh, if we consider a ball, so you consider a ball and take the north pole and south pole, so they in anti-clockwise they rotate the earth, and earth is also rotating on its axis. So basically what happens is, at a time it covers whole of the area and come back again at the same position after some time, so based on the its orbit speed. So this is the high resolution satellite group, where we are getting the examples are like Landsat, Sentinel, and other Indian Earth observation is Cartosat, ResourceSat. So these satellites are like uh, Earth, polar orbiting satellites, which are rotating all the time opposite to these poles. And these are actually low temporal, we are saying is, so this is the temporal resolution, we'll explain later on. So temporal is related to the time, and the cloud cover, this is the global coverage. So these satellite actually give the global coverage. So whatever the data we currently we have in open source platform, so whenever we go to, like we want a data set, we are doing some research on some specific topic and we want data at India, then the same area we want in Africa, US. So these are the only satellites we are covering most of the area. So we uh, target those things. And other one is the geostationary satellites. Basically, these data sets are not uh, very much available in the public domain, because specifically they are being used in the communications and meteorological aspects. And geostationary means these are all the time, these are seeing a same area on the earth. So what happens is, they are actually rotating, but they are rotating with the speed of earth, and they are kept at very high altitude, because their field of view is small. So cover the whole country, their most of the like height is like elevation is 35,800 kilometers beyond that. So that it can cover maximum of the country area. And because of this, they are like having low resolutions, mostly 1 kilometer to 4 kilometers we are getting for Indian aspect, I'm telling Indian satellites. So uh, and their coverage is limited to the country, a specific country which has launched the satellite. And they are, but how they are different, actually they have very high temporal resolution than the polar orbiting satellites. They can deliver data within minutes to the hours. So basically in our Indian sector, we are getting rapid scans of every 4.30 minutes, like 4 minutes 30 seconds mein we are getting repeated images when the calamities are happening. Otherwise it is every 15 minutes, because we have two constellations of insect, and it is set in a way like every 15 minutes it repeats, like sends the data. So this is for the type of satellites rotating around the globe. And this is like how satellite make the measurements. So when the satellite is rotating, so it's always seeing the earth in vertical way, fashion. So and it is rotating also. So some of the times what happens is when the data getting recorded and when we retrieve the first product of the data, it has a lot of distortions in it. So we correct those things, but its job is because to collect the data vertically to avoid vertical you can say the shadow effects and to get the proper height and other things. So what happens is as I told earlier, basically satellite sensors are installed with the CCD, and those actually devices are very, very, very sensitive to the light actually, and that light getting recorded whenever it is reflecting back to the sensor into the sensor, and it has some numbers recorded on that, and those numbers are revert back to the earth stations, and where then we are converting then radiance data to geospatial parameters and then pixels, and then there are a lot of algorithms we have developed for, because it is keep changing things. So we cannot keep the same algorithm for all the things. Every time we have to change, because every time it gets degraded also. It has some lifespan, so with the time it start degrading. So as it is start degrading, we have to rechange, remodify our modules also with algorithms, so that it can produce better images without noise and the corrections also. So so as so this is the one factor we when we see any image. So first questions arises, what is the resolution basically. So most of the time we talk always about the spatial resolutions, but there are it is categorized into four classes: spatial, spectral, temporal, and radiometry. So uh, we will explain one by one what is the like how things are going when we talk about resolution. So first is the spatial resolutions, which is the very common term when we see our Google Maps and other things. So whenever you see any satellite or any map, there is a scale in the corner, left side, most probably in left side corner. So it says the resolution also, or sometimes they reflect also, like what is the resolution of the image you are watching at the current level. So as you see, uh, we say generally low resolutions, medium resolution, or high resolution, spatial resolution. So resolution basically means the resolving power of eye. Okay, or if I say when you are seeing on satellite image at the particular moment, the object you can see, the smallest object you can identify in an image is its resolution. So when we are seeing a satellite image is of having spatial resolution, spatial resolution means in that image we can identify objects of 0.5 meter and above. When same way when we say 1 meter, so in that we can't identify object less than 1 meter. So always it is like that. So if you see like 2 meter, 5 meter, so it's like 10 meter, 20 meter. So these are the actually resolutions based on the object features identify on the satellite image. This is the way, or in other way also we call it like pixel size. Like what is the pixel? Basically we may technically we measure the pixel of a image, and if it is like 0.5 meter by 0.5 meter, so like that it's a both way we can say. So technically like that, and theoretically what I say is like the smallest unit we can identify on a satellite image is the spatial resolution. Second is the spectral resolution. So spectral resolution is like when we see a satellite image, like not on the Google map or like any mapping source, when we see the satellite image as a raw data, and on the software when we open the data, it has number of bands, and those number of band clubbed together to build satellite image of some index, like natural color composite or some kind of composite. We build it by clubbing the bands. So basically spectral resolution define those bands, number of bands a image is like an image is having. So basically if we, for example, if we are talking about Landsat 8, so 9 bands, or Landsat uh, this sorry latest Landsat 8 9. So uh, it has 11 bands. So like it has different those bands are having different frequencies. So like one band is of blue, green, so it is mentioned there. So they always, satellite image comes with the metadata information, like every band is having what kind of frequency recorded into it. So this is the spectral resolution. So when we say ki like it is a multispectral image, it is a hyperspectral image. So it's the spectral resolution of the image, like how many bands in one short wavelength we can record. So basically hyperspectral, for example, in from 0.1 to 2.5 micrometer, a multispectral sensor can record 11 bands. Okay, but parallelly a hyperspectral sensor can record 25 2100 bands within that spectrum, which can have more informations, more features, more objects can be recorded, more elements can be recorded into that, and which are more useful to us. So basically that defines the spectral resolutions. Second is the temporal resolution. So this is very like basic model I have built. So if you see this circles, you consider these circles as a satellite, and this satellite is just taking the data. So red circle has taken data on July 1st, and the second data is had taken on July 2nd. So like it has a 11-day of time span of taking data, second data set of the same location. Like it is taken. So don't consider the map behind it. Okay, you just consider July 1st it has taken data of Mumbai, and after 11 days it has returned back to the Mumbai and taken the data one. So it has taken 11 days to take the Mumbai data twice, means again to reach. Other one is taking 16 days to reach Mumbai in a cyclic way. Okay, so we are saying this is low temporal, this blue one is having low temporal resolution, and this red one is the high temporal resolutions. So currently we as a multispectral data set, we are having high resolution temporal resolution data sets. Also, like when we talk about Sentinel, it can revisit within 3 to 4 days, which is quite a good data set when we talk about multispectral. So we have improved. Earlier it was very less, like 7 to 8 days we are getting a data, hardly, means sometimes we are missing that also. So it was very difficult to monitor small calamities like flood, which is for very short period of time. So now the data are like this temporal resolution has improved. Actually, the main focus to improve the resolution is the temporal resolution, because we need because everything changes very fast on the surface, like anything. So we the demand is for real time monitoring system. So for real time monitoring system, we have to improve our temporal resolution into real time. Otherwise, we cannot. We have to only talk about the real-time monitoring systems. So when we want to set up a real-time monitoring system on the satellite, we need to improve our temporal resolutions. That's it. So this is the temporal resolution. Other one is the radiometric resolution. So in radiometric resolution, what shows? Just a minute. Yeah, yeah. So it actually explains the amount of information recorded into the information, this set images. So it's 6 bit, so 8 bit, 10 bit. So it's very easy to understand, like more bits are there, so more of the information getting recorded into the bands. So it's all about the information getting recorded. That's it. This is the radiometric resolution. So it is directly related to the size of the image also. Most bigger the size, bigger the information into that. So uh, yeah, so after seeing all these things, after getting the data, like there are first of all I will showcase some of the data, like some of the resources where we can get nowadays. Data is in open source platform, so it is easy to access the data free of cost. Some of the, like till 30-meter resolution, or now since 2018 onwards, we can have 10 meter of resolutions also, which is in open source. So NRSC ISRO is also giving the open source data for from the lease tree, which is 30-meter resample data sets, and it is processed data. So it's a good data set. We can have a look. We will in the training period we will see how to download the data and see what are the informations are available on that. Other one is the big platform is the USGS, which is the leading sector, which is the leading organizations to deliver the data from the Sentinel, this Landsat series. This, then the ESA Europe, which is giving data of the Sentinel, and Google Cloud Form platform also. So one of we talked about hyperspectral, multispectral, but parallelly we are having one more data set, which is the digital elevation model. This is the 3D data. Okay, so parallelly we actually, this data doesn't update very frequently because it's elevation, so profile doesn't change that much frequently. So uh, this is also kind of data we need to integrate whenever we are doing any specific studies on the surface, whether it is related to geomorphology, geology, geography, or any feature related things, whether the topography is very drastically changing. So we always integrate our digital elevation model data, which is uh, kind of, you can say, 3D data sets. So actually that data records elevation factor actually into the satellite images, and that is like, there are 3 4 satellites which are open source, like Aster, Cartosat, SRTM, and Elos Pulsar. These are the very popular data sets available, global data sets available free of cost for 30-meter resolutions. But for your if you are a research scholar, if you want to integrate into your PhDs, you can ask for higher satellite data, as our new policy says. You can ask for high resolution data sets, for example 10 meter, which is a very good data sets from the ISRO satellite. So it is available. You can write to the NRSC database center, they can provide you for your research aspects, and the data is fantastic. So in this whole process, after actually getting the data uh, at level 1, first it requires a lot of pre-processing to build the data, because when we capture the satellite data at the first moment we receive the data, it has a lot of noise, a lot of bands, means hardly you could see anything on the satellite image. So we implement a lot of algorithms for noise removal, haze corrections. So a lot of atmospheric correction, a lot of these corrections, this image becomes visible, or it's ready to like identify features and other things. Then later on, then we take to other level, and then we do layer stacking, band combinations, subset, mosaic according to our area of interest. For the classifications, we use supervised and supervised, decision tree, random forest, obia. Like, these are the actually methodologies we to extract the information from the data sets. And the indices for agriculture we use to get different indices like water index, uh, vegetation indices are there, soil indices are there. So identify these features, we implement these indices on that data set. Then spectral signatures, specifically if we are focused towards any particular feature, like particular crop, particular type of tree, particular kind of concrete material, or kind of any kind of particular specific. So then we target the reflectance pattern of the satellite material images. So we compare with the reflectance, and we take out the signature, and we plot this signature with the spectral libraries we have. So on that library, wherever it is matching with the object, we then confirm like is so and so object. So finally we prepare with, like, after all this we come at the concluding platform, like we develop some applications, some dynamic maps, cartography, and a lot of other things we can do with that. So this is actually data generated by my lab. uh, so this is actually a kind of example I just would like wanted to show you, like how, what is the difference between the spectral signatures of multispectral and hyperspectral data sets. So this above the black line, if you see, so it has very like coarse pattern. So because of low um, bands. So when we talk about the spectral resolution, so this is the actually story behind all this. So it has recorded 1 2 3 4 5 points, only 5 bands it has. So that much actually only we can get. But actually if we go for hyperspectral, so within this spectral signature limit, it has recorded around 1500 bands approximately, where we can identify even the gaseous element, even the smallest oxidation material, particle, chemical compositions of that area, moisture. So most of the maximum information we can identify through this whole spectrum of hyperspectral data sets. So this is kind of, if we normally, if I say like this is the very low at low, because of the water content into the soil, it is showing the low reflectance. As the water content start reducing, this is in the morning. So this is from 9 to somewhat 12 o'clock kind of period we have recorded. So it, as the moisture start reducing, the reflectance started increasing, so it has increased here. So a lot of other things also, like these noises are coming because of the oxygen available into in our atmosphere. So it is very sensitive to oxygen also, so it responses to that one. So this is just one example I wanted to show. This is actually visible and switch channel of our INSAT 3D satellites. We wanted to validate, so we have taken the data for that only. So these are the actually application sector of remote sensing, where we are currently using all our aspects, so like agriculture, ocean, disaster management, climate, water, urban development, pollution, soil, forestry, agroforestry. So this is actually the broad field of its applications. But these are actually, this application part of remote sensing is totally limitless. We can implement anywhere. So recent trends are, these are getting implemented in the hospitals, into the medical industry. These are getting implemented into the banks, into the banking sectors, where we doesn't expect this technology could reach actually. But it has grown in last 2 3 years. It has grown drastically by you, our statistics showing like it is running with very, it is showing the vertical growth in last 4 5 years. It's like totally tremendous. So because it is, everybody wants their data to be geofuel. So everybody wants to integrate the location based services to their data set, so that it can have better presentations and better understanding of the data with, it can be integrated, because once the data is geotagged, so it can integrate with a lot of other stuff also. So this is kind of some of the data products we just have shown. Like later on we will see in detail. So uh, now this till here, I just I think at broad spectrum, I have just shown you the remote sensing domain, like how it, we capture the satellite data, take the informations, and how it works actually. And now is tool part. So why GIS? Basically, uh, people sometimes mislead with the GIS, because GIS is totally different from the remote sensing. It's a tool. Remote sensing is a technology, and GIS is just a tool. So tool can be implemented anywhere. Okay. So as industry people, like it's a global term now. GIS is the new oil. So everybody is talking on this, whether it is Europe, US, wherever we think about, like the people are very expert in these areas. But whole globe is talking about this, and this is the new oil. Why we are saying it is a new oil is because the data flowing, the industry growing, everybody, whether it is a transportations, railway, every industry is coming into this. So everybody wants to use this as a generator, and they are just hoping we can get upliftment, we can get a pace, or we can get a new network system by using this technology as an industry perspective also. So it's a very right term to say a new oil, GIS is. So yeah. So this is the whole environment of GIS, how it works, what it is actually. So GIS basically is a geographic information system, as we call it, and it's actually integrated tool, and it is directly associated with the remote sensing part, which deals with the what, where, how. Okay, so basically it links the database and map, manage information about places, okay, and the questions like where it is, what it walls is nearby, like these questions when it come like where is the highest corrections of X, where can I find things with characteristics Y, where is the closest Z to my locations. So all this like when we queries, when we generate queries, so these queries getting resolved by this GIS system only. And this system actually is everywhere. Like you can see, like crime management, survey application, emergencies, municipal traffic, infrastructure, land resource, geospatial application, agriculture, forest, hydro, everywhere, meteorology. So this is a very very big sector, and to understand it better, like we have to see around everywhere. If you see around now also, so most of the applications you are using in your phone are GIS enabled, whether it is uh, e-commerce firm. Every day we are using this only. So everybody is reaching, getting connected to you because of this technology. Otherwise, it was not possible, like to get connected. So nowadays we can order anything anytime, and without telling, the person can reach to us. So this is what GIS is doing. It's simplifying our life. So this is kind of one example. Recently, I have developed for a team of ISRO and IMD collaborated team. They are actually working for the meteorological satellites validations. So this team actually wanted a real time. The challenge is, it's actually just a practical example I wanted to show how this is simplifying my research, okay, or anybody's research it can simplify. So the challenge was, when we are going to the field, we are getting a lot of questions in mind, like how, okay, we are standing at this location, we got the data, one data we got, and we then after getting the data we got, why this data is showing this kind of pattern? Can't we have our back 10 years data immediately on the go? So no, like either we have to carry a lot of papers, like this is huge data, so we can't carry on papers every time. So okay, thought no, okay, can we see the picture like 10 years back, how was this environment that time, okay, through satellite images or some pictures. So all those things, so I thought this is a good idea to like test the real time mapping in the field. So I have taken the whole last 10-year data set into the mapping platform, and photographs, everything is just integrated there. And we have taken to the mobile there, okay, immediately we got, even we wanted to check, for example, like we are taking a location here, it is showing different, but we wanted to cross verify our last 10-year location where we have done last reading. So when we reached there, it was a watery area, means I thought okay fine. So if in the below last below image you can see how the tracker is working to like to telling the last previous locations. It is taking to us in 2020 we have taken the data. So it's like very easy, it's become very easy. So earlier how it helped is, earlier we would able to take in a day like 15 readings, but this time it double. In same time period we have taken double readings, like around 35 30, and very easily. We need not to hunt for the locations, nothing. And it has generated like very very useful. So it's like we need not to develop or we like set up a build platform, like we need not to invest a lot of money into this kind of, with our surrounding resources, like we have good um, geospatial like positioning system in our phones, laptops, okay, integrated devices are there, we can integrate those devices with our instruments and take to the platform, like we can do a lot of things. So this is kind of one example I just wanted to show, like how it can help in different way. So anywhere you can implement it. So this is kind of we thought idea, and we just implemented and work well. So and now this is just a market scenario research. Actually, this I'm working on for generating some data, like some ranking. So actually, this ranking, this is a ranking of 1 to 25 as a geospatial infrastructure, where we are and where other countries are. So generally, we think a lot of things are going on in India. Everybody is talking about, but still we are at 25 rank global. in the geospatial infrastructure. But still, if you see the um numbers, those are just amazing. So by when we are talking today, so Indian geospatial market has reached to 1.56 billion dollars, which is huge, and half of the part of this is getting exported, because India is because this should be very cost effective. So India has, when they started, they themselves have developed in such a way it is cost effective. So most of the our like topmost countries, it is very cost effective. So a lot of our geospatial technology getting exported. So it's used, and a global geospatial market is about 450 billion dollars today, as if today, and we are the rate it is going to grow is around 13 to 50%, and it will reach 675 billion dollars by 2025, which is a huge sector. Okay, so this is small about the industry, how it is going. So thank you so much from the my side. Any questions? Most welcome. If any specific questions on that.
Sir, may I?
Yeah,
Yeah, sir, in your very first slide,
yeah.
yeah,
This one.
yeah, this one, sir. There is a term called as phenology. Sir, can you briefly explain that?
Eh, that's why I'm actually I mentioned here is the source nature. Okay, so basically this is for some ecology system. They have developed a model where they wanted, it is only one area. I'm not that's why I told this model is for only one area of ecology, some ecology environment, where they have used this remote sensing for environment studies, composition, function, phenology. Phenology is a term like a environmental term, so I can't define in much specific way. uh, it's not specifically for the this whole domain, so it's for that only. So this I just kept for have a picture, because every structure is just work in same way what it is showing here. Okay, so other domains also have different names here. Like when I talk about the land use, so it will be having the cadastrals, uh, taxations, so all those things it will come over that.
Okay, sir. Thank you.
Yeah, any other questions? Most welcome. Like related to applications area also, you can ask, like any specific area I left, I missed, you can ask.
Yes, participants, any questions?
Parallelly, what we can do is like this is because in this kind of actually presentations, we have very less time to explain most of the we to cover most of the areas actually. So later on, if you people want, or people want to know more about that, so we can have a very good session, like hands-on session on specific domains, so where we can understand better like how it works. So like it is just a collaborative one, so like if you want, later on someday we can
Sir,
plan that one. So
one question is there in the chat box by Ms. Purnima. Any hands-on project that can be given to the students related to this topic?
sorry, hello.
Hello, sir.
Yeah, yeah.
Any hands-on project that can be given to the students from this
Yeah, yeah,
topic?
yeah, yeah. Lot of we have lot of projects in all the domains, whether it is agriculture, soil science, electronics. Also, we have that domain. Civil engineering, we have indoor mapping projects. It's a new thing, because I could not discuss here like this. It's a totally different domain. But for civil also, there is a indoor kind of mapping we have brought developed this time. So we have hands-on sessions, practicals, projects. We have a lot of things. If people uh, and I would like to invite people like students to come forward and contact. We sometimes we keep on running a lot of projects on satellite image processing and related applications, so they can come and have good experience on that, because this data, the data I'm talking about, that is not for public domain. Only you can come and have the experience of those data sets here in the organization itself. But here at geospatial world also, we have our knowledge infrastructure division, which deals with all this kind of training programs and other things. So yeah, you can contact for anything, any kind of collaborations, any kind of trainings on specific topics. We do a lot of knowledge infrastructure developments.
Sir, do you offer internships also to the student?
Yes, yes, yes. We offer internships also. We here at Geospatial World also we offer internships, which is having very good. We have very good platform to interact with global expertise here at the Geospatial World. We have a network of this very strong network with the expertise of like remote sensing and the GIS domain and industry also. And parallelly, we I can they collaborate students with the this India Meteorological Department as well as the space Indian Space Research Organizations also, because there also they have their outreach facility where we can come and participate. You can ask, because every year we have a calendar for our this outreach facility where we are offering different trainings for Bhuvan. Bhuvan is like ISRO's geospatial platform. So there we offer a lot of training for professionals, students, faculties to come and learn about the application sector of remote sensing and GIS, how to build, how to create, and all. So it's a hands-on. You can come there. They have the facility. So I was the part of that when I was there. So, but still I am connected with them because yeah, it's ongoing process. So still we I am connected to them, building a lot of tutorials for them.
Sir, is there any prerequisite required for a student to apply for such programs? Means pre-knowledge.
Yeah. So basically, when we say ki, yeah, we offer some training program to the students. So in some not all, but in some, most of, like half of the, you can say, training programs, we require basic programming knowledge. When we focused on the satellite trainings, satellite data training, because those trainings require a lot of image processings, and that students when they are coming, so that maybe in multiple numbers, so that time we don't have that much of enterprise editions, image processing editions. So we moreover focused on the open source facilities there, like um, mm, programming part, languages like Python. Basically, we are focused on the Python and JavaScript. So it's basic knowledge only required. If it is not, so uh, we can take into other one, like application different. Other than that, we have the application areas also, where we can take the students to do the research on software like MATLAB, NV, ADAS, global mappers. So we have multiple softwares where people can come and learn other things without software. This program is for both, like non-programmers, but yeah, it's a good like it's an add-on. If it's a plus point for them if they know the basics of some Python or JavaScript.
Sir, as you mentioned the indoor mapping system, so
Sorry.
can you indoor
Yeah, yeah,
indoor
yeah,
map,
yeah, yeah.
so can you just elaborate what indoor mapping you are doing and what technology you are, because there are various different technologies are there.
Yes, 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 yes. Actually, we
So
have here. Yes, yes. So we have one our domain here, which is focused on this uh, civil engineering sector, and they are mostly looking for this indoor mapping, which is we have collaborated with this Leica and what Garmin. So they are building different instruments. They have different laser instrument scanners integrated with GPS systems. So basically what they are doing as if now, because as I go through this whole process, so I was just understanding ki, what is the like techniques they are using. So basically what they are using is the
Sir, you are on mute. Hello.
Okay, sorry. So basically, uh, so what we are doing is like when in this civil indoor scanning, we have our digital laser based scanners. Like it's not ours, basically those industry people are doing. They have developed their scanners integrated with location based services. So they scan basically digitally, they scan and they prepare a digital virtual map of the whole building system, you can say, or mega structures. And what how it is helping. For example, if some leakage is happening at some location which is at 25th floor, okay, so we don't know like how to use there. So immediately it is, everything is location based. So immediately you can get the coordinate of that location from that virtual map, and you can hit the target like where it is happening. So this kind of mapping actually people are doing nowadays for indoor civil engineering mega structures. So but yeah, we have a lot to know about that, this because this is actually my different domain. So we can contact later on to understand more about that. We have our whole one magazine on that, like civil engineering indoor mapping.
Sir, is there any scope in this area for what you can say the telecom engineer?
For yeah, but there is scope for all the domain people. Only thing is they must have basic knowledge of geospatial infrastructure, like how to integrate it, how to develop, how to build this, or like because whenever you come into this, so you have to generate an architecture which is geospatially smart. So the requirement is like, because when you come to the industry, the people are not from the geospatial industry. Okay, so most of the people are from different domains, but the common is they everybody knows the geospatial technology to integrate into that. So yeah, it is open for all.
Okay, thank you, sir. We would like to collaborate or work in that project because
Yes, yes,
from last
definitely.
year,
Because recently we are working with Larsen Tubro. You must be knowing. So Larsen Tubro, they have their own geospatial division just to do this kind of activities,
mm,
civil scanning. So in their
we are
mega structure, they are using this technology now.
we are working in this area from last year, but nothing concrete we are able to get in this area. So
Okay,
we'll be
okay,
happy.
definitely. Yeah, we will help you, don't worry. We would like to help in that, and mostly uh, we will try to build your connection with the partner organization, those who are actually working into this specific domain.
Thank you, sir.
Okay. There are few more questions in the chat box. Can you take
Yes,
those
yes.
questions? Archana, can you ask?
Hello, ma'am. On behalf of Archana, ma'am, I'll take the questions.
Okay.
Just a moment. Uh, Rashmita, ma'am,
Okay. Yes, Sujata
can
ma'am.
you just take them because I got logged out and logged in, so there is a loss of
Okay.
data here.
Okay, I'll
Thank you.
read the question. So, what are the research areas in the remote sensing and GIS applications?
Okay, so basically but on that I would like to like counter a question. Is like at at what area looking, like you are looking for, basically, because it's like it's a very broad question. I can't answer like it's in one area. As I told, it is everywhere. So only I can answer it when you say ki, like my interest is this area, so I can answer like
So,
what are
there
the
it
things
is written GIS applications.
in GIS applications.
Yes, yes.
Yes. So in GIS applications, for first of all you need a basic data. So once in applications part, this is the most actually growing sector in GIS, the application part, because people are having the data, they are integrated. But everybody's focus, industry focus is how it is benefiting the people basically. So everybody is like, you have the data, it is waste until unless it is not into the public domain, or not into a domain where people are using it like for their benefits. So until unless you can't do it, okay, like much on that. So you can build dynamic applications, because earlier what currently is going on in the application sector, we were having the applications earlier also, but those applications were not dynamic, static applications. So we are transforming those applications by integrating new GIS techniques to make it dynamic. So we are giving freedom to user to come and play on the data, because we don't want a user to come on the application and just to have a look and go back. No, that actually kills the interest of user to come again. So how to generate the interest of user? You make it very dynamic and representable. Okay, don't use basic cartography, you use the advanced sandwich cartography, where we can integrate, like it should be more of kind of playing the game on that. Okay, you just leave the data set with the user and leave the information with the user. So let user extract his own area of interest. For example, if I am a user, if I am going to any application, so I have some interest on some specific area, so I just want to explore that part. I am not interested to other part. So if that facility is there, every day I will go there. Okay, so if good example is, everybody is using these weather forecast applications. Okay, so you like that application much more, which is having very precise locations. Okay, like for example, that if that app is giving the only forecast for Mumbai area, you will not be interested. But in Mumbai, where you are located, if that information, that app is showing that area, you will always come to that application and see like what is the weather and all. So this is the actually difference between the application area. So yeah.
Yes, sir. So there is another question. Which free
Yeah.
softwares that can be used for student projects?
Yes. So there are there is one very popular software everybody uses, QGIS. Okay, so it's both raster based and vector based also, and it is fully open source, customizable, and it's a very good software, I would say. And it can actually it can mimic all the enterprise editions which is available in the market, like ArcGIS, Global Mapper, Map Info. So these all the softwares actually, what are the features available in these enterprises? These softwares cost around 45 lakhs full package, one software. And because when we go for softwares, these softwares are not very cheap. Any software if you buy, like there is one software GXL we bought for 4 crore 1 year license. So for just for image, satellite image process. So these are very expensive. So that's why everybody is focused toward open source platforms. So there are actually, that's why people are more towards the programming languages. Programming languages have the libraries for satellite data process, geospatial libraries. Every day it is getting increased. So what is happening is there are a lot of libraries for image processing. People are finding on the this programming part. So they are just going, installing the library. From that library, just they are putting the queries and getting the data. So why I'm telling, and another one is this is Google Earth Engine. Okay, so Google Earth Engine is like a god, you can say. Is everything, is a database, is a software, is application, everything they have brought at one platform. Everything is at one platform. So you can access data, you can run your model, you can run your queries there, you can build your application, and you can host. So all the things you can do at one place without having any software, without any infrastructure, anything you can do on that. Only thing is there you need a small, like, basic programming knowledge. Otherwise you can't do that, because that runs on program. That's why I told you open source is more focused toward programming languages.
Yes. Okay, sir. Next question is by Sunil Khatri, sir. Sunil Khatri, sir, can you unmute and ask the question? Sunil, sir.
Yes, ma'am. Good afternoon. Yes. Thank you, ma'am. Good afternoon, sir.
Yes, good afternoon.
So I wanted to ask how much time want to know why is need to properly learn GIS softwares and develop some sort of minor projects, and
Okay.
could share some few reference websites for students or
Mhm.
faculty members to learn for GIS.
Yes, yes, definitely. So, as if now, like I have a listing of some of the satellite sources where you can come, you can go and have like training kind of sessions. But practically, if from the learning perspective, if I tell, so going there and understanding is very difficult, because it requires a lot of technical knowledge also. So if you, it is totally different from the theories. What is written in the theory, it is just written, it is a band combination, you implement this and that. But when you go to deep, the technical part is totally different, the methodology itself is different one. So yeah, but by doing, getting a professional training, uh, it can resolve your this challenge. But the training period doesn't require much of the time. It's like 1 week continuous training if you do, so you can cover most of the areas of this sector, like image processing, data management, data creation, and application building also. Because now application building has become very easy task by open source softwares, where you can just bring your data, implement your queries, put your thresholds, and just export those on the web portals, like web format. So it has the engine to convert whole mapping scenario to applications. That application you can directly host. Only thing is little bit the modifications you have done in the data part only. So the data should be automated, like every day. If you want to make it dynamic, so like data should be changed every day. So like you just have to put some kind of uh, scheduler, so that it can replace everyday data which is coming from your sources, like that. So it doesn't take more than 1 week.
Thank you, sir.
Okay. So next question is by Yogesh sir. Yogesh sir, you can please unmute yourself and ask the question.
Hello, sir.
Yeah, yeah. Hello.
Yes, sir. Actually, there is one project. There is a requirement of one project,
Yes.
drone-based uh, water searching underground.
Mhm.
So, drone-based GIS for agricultural. Is it
Yes,
possible?
yes. Yes,
Yes.
bilkul. Yes, this is possible. And in agriculture and the water sector, specifically you mentioned, only maximum drone technologies are being used actually, because of the high resolutions and independent of time. Because what is happening is, when you are telling the agriculture and water, okay, these two areas you want to focus. So in agriculture, what is happening is, we want everyday data, but it is not available nowadays. Okay, and in Indian agriculture sector, what happens is, we don't have very big fields like US and Europe countries. Like they are having fields of 1 kilometer. We have a field of small, like 100 meter or less than that. In that also, people are growing multiple crops, 2 3 crops. So that is the challenge, is like how to identify those crops. We can't identify with this coarse resolution satellite data. So just to come over that, we have started using UAVs, drones, and drones can produce data of centimeter scale. Okay, where we can easily identify the uh, crops types, the varieties, its health, yield estimations. And in the water sector, we can identify the moisture, soil texture, flood also we can mapping. So this this is very useful, very useful. But cost effectiveness is what matters here. It is expensive. So nowadays, uh, lot of startups is offering small, like small drones for very cheap prices, like very less cost. So people are adopting nowadays this one. So in future, this is the like going to be game changer for agriculture sector specifically, because we are still finding uh, problem with the satellite data sets. It is not up to the mark like cyclic data sets.
Right, sir. Thank you, sir.
The next question is from Dr. Sujata. Yes, ma'am.
Yeah.
Yes.
Thank you, Rashida ma'am. And thank you, Abhimanyu sir, for such a good session. Sir, actually, I wanted
Thank
to
you.
ask that are there any free available data sets for hyperspectral data?
For hyperspectral, actually, we don't have, as if now we don't have any free data sets. Only the thing is available with is the hyperspectral radiometer field spec with 0.1 to 2.5 micrometer, and this is kind of expensive stuff. And but yeah, you can use this one. Okay, this instrument you can use
How can we
to
get the
get
data,
info.
sir?
Huh?
How
This
can we
instrument.
get that data, sir, directly?
Okay, actually, what?
Huh?
Yeah, this is a good question. Actually, you have to find out in what institution this instrument is available first of all. Okay, and you ask the permission. Like either you have to collaborate with them so that you can use this instrument. But this instrument is fantastic. Like, the results are tremendous, and this is not available everywhere. Actually, this is like it costs around 80, and with tax it costs around 1 crore. This is whole instrument, and handling is like not can be done by one person. At least 3 people are required to handle this data, this instrument. Okay, so yeah, this is the only instrument available. This is the ground based instrument. Space based instruments we have Hyperion and other things, but you can't extract the information you required with that. Those are 120 band data sets, and 120 band is not actually enough, and most of the area it is taken from the space, so it is covered by the vegetation. So you must be interested into the surfacial features basically with this instrument.
And
So yeah, so that's why only this instrument is like currently being used in the industry. So yeah, we are hoping for new upcoming satellites by the ISRO also, but the thing is key, they will not be into the public domain. That is for, I think, for defense purpose only. Okay, so still we have to wait for hyperspectral space-based data.
okay. Thank you, sir.
Okay, thank you, sir, for giving a brief idea about the remote sensing, GIS, and its application. Thank you for taking time from your busy schedule to be the
Thank you so
keynote
much.
speaker of our FDP. Your presence
Thank you so
is,
much.
yes, sir. Your presence and informative words helped us to magnify our cause in the best possible way. And I hope all the participants benefited from this session.
Sure. If not benefited, we can come again on the same platform some other day. We can start again this, and until unless not
Yes, sir. We
benefited,
can collaborate
I,
with you
yeah,
as
yeah,
Dr. Dongre said.
I would be
Yes,
happy to like bring people on this platform. This is my job.
yes.
Thank you.